Hello, welcome to today's webinar on the Michigan DOT's digital journey. This webinar is one of a series hosted by the AASHTO Joint Technical Committee on Electronic Engineering Standards. I'm Patricia Bush, Senior Program Manager for Bridges and Design at AASHTO and today's host. Before we get started, a few housekeeping notes to help you enjoy today's session. All attendees are automatically muted for the entire webinar. If you have questions at any point during the presentations, you can submit them by using the Q&A button on your Zoom webinar control panel. We will answer them as time allows at the end of the presentation. This session is being recorded, and the link will be made available on the Joint Technical Committee on Electronic Engineering Standards webpage. You can navigate to it by going to transportation.org/design and selecting Technical Committees, then Electronic Engineering Standards from the menu on the left. An email with a PDH certificate will be sent to all registered attendees later this week. If you can't find it, be sure to check your spam or junk folders. Download the certificate and keep it for your records. Now I'd like to introduce today's moderator, Jennifer Lloyd with the Tennessee DOT and Vice Chair of the Joint Technical Committee on Electronic Engineering Standards.
Hi, everyone. I want to introduce our speakers today and thank them for attending and doing this session for us. We really appreciate it. It's a lot of work to get this together, and welcome back. We've started these back up, so we have several planned for the next 6 months. First, I'll introduce Brad Wagner. He's the Deputy Chief Bridge Engineer for Michigan DOT's Bureau of Bridges and Structures. He oversees staff involved with structure design, construction support, and geotechnical services. Brad has been a longtime champion of BIM initiatives for MDOT, including both pilots discussed in this webinar, in addition to several BIM-related research projects. He has also been heavily involved in Phase 1 and the current Phase 2 of the BIM for Bridges Pool Fund. Melissa Donoso is a Bridge Design Unit Supervisor for the Michigan DOT. She has been with MDOT Bridge Design for 11 years. She serves as a project manager for in-house bridge design projects in her unit and is currently working with MDOT's second mall pilot project. Luke Arnold is the roadway modeling specialist for MDOT's CAD support group. Prior to that, he spent 7 years as a roadway designer for MDOT. As the roadway modeling specialist, Luke helped lead MDOT into using the Connect edition of Bentley products. He produces training for roadway designers and assists in managing the MDOT CAD workspace. Turn that over to you.
Thank you. I'm going to take over the share here, and I think Brad's going to give us a little introduction.
All right. Good afternoon, everybody. And thanks, Jennifer, for inviting us to share a little bit about what's going on in Michigan. So just real quick about the flow of our presentation today. So first up, Luke is going to give just a little bit of a background on several steps in recent history that have led up to our model delivery pilots. And then he's going to give some information about our first model delivery pilot that was completed last year. And then Melissa Donoso, who is the project manager for our current model delivery pilot, is going to talk about her experience and kind of where that project's at. And then to wrap us all up, I am going to highlight something we're calling our digital vision and kind of the journey that we've gone on to get there. So with that, I will turn it over to Luke.
Thank you, Brad. So to start out, I have a little bit of a timeline, actually going all the way back to 2005 of different pilots and different initiatives that we had going on at MDOT that have kind of brought us to where we are today. And so my goal for this part is to take you on a little history tour, and also to elaborate on some of the feedback that we've gotten on some of these pilots. And it was actually all the way back in 2005 when MDOT did our first automated machine guidance pilot project. And in talking to some people around MDOT, this was before I was with the department. I didn't start until 2012. but I couldn't really find a ton of information on the project. I think it was one of those things where the contractor came to MDOT and wanted to use automated machine guidance, and we actually developed a 3D model for them and gave it to them on their project. I couldn't really find a ton of feedback or information about it, but as far as I know, that's the first time at MDOT that we used automated machine guidance, or AMG, on a project. The first time that we required automated machine guidance, though, was in 2007 on what was branded as our Mach 1 pilot, which I'm going to get into in a little bit. Just some other notes here. In 2012, we started requiring that CAD files be delivered to the contractor on every project as part of for information only, so non-contractual. But that started in 2012, and then in 2015, we started requiring 3D design models, so surface type information be delivered, again, for information only on any project of a certain scope or of a certain category. But looking back at this 2007 Mach 1 pilot, there's a lot of interesting stuff that I found going back and looking at the proposal and talking with people from MDOT. The first thing that I thought was interesting is that we actually required the contractor to use automated machine guidance. So usually we try to stay away from things like means and methods, but in this case, we actually told the contractor, like, hey, you need to invest probably hundreds of thousands of dollars in equipment in order to pilot this technology for us, which I'm sure we got charged for it, but interesting that this is the route that we went when a lot of times, again, we try to stay away from means and methods type stuff. The other thing that I found really interesting about this project is that the same files that we delivered to the contractor, 2D CAD files, 3D digital terrain models in land XML format, it's literally the exact same file types that we deliver today for, at least for the purposes of automated machine guidance. When we get into model as a legal document and things like that, that's kind of a little bit different type of information. But as far as surface information and AMG, same exact file types that we were working with back in 2007. And I got a chance, the person who made the 3D model for this project still works for MDOT. I got a chance to talk to him. And he said on the contractor side of things, the project went horribly, which I thought was hilarious. I guess the contractor, they couldn't get any of their equipment to talk to our CORS network, which allows you to get like really highly accurate GPS signals. And so a lot of the project actually ended up being staked conventionally by hand. But they did end up getting their AMG equipment working. I'm not sure exactly what the issue was. But it's funny to go from 2007, when this was a new technology, to today, where at least in Michigan, it's pretty typical for automated machine guidance to be used on a project, at least on a lot of our larger earth moving projects. And this has kind of led the way and paved the path for some of the other stuff, some of the other initiatives that we've done at MDOT. In 2017, we had our first project PDF pilot, which I'll talk a little bit more about that and some of the feedback that we've gotten. At the same time, we started delivering certain portions on some projects as contractual information. So basically 3D lines, the alignment, the edge of pavement, things that we could be really confident were modeled really accurately. Keep in mind that even on those pilot projects in 2017 and 2018, they still came with a full plan set. And so the model information was in addition to the plans. And just some other notes of some other things that have been going on. In 2018, the BIM for Bridges Pooled Fund started their project, which led the way for a lot of the BIM standards that are being developed now. And I think we have another timeline of some of the more recent pilots as we get into Melissa's portion of the presentation. But I did want to start out by talking a little bit about some of our project PDF pilots. So basically the idea of these pilot projects was to not think of a sheet of paper as an 11 by 17 thing that you have to print out and carry around with you on the job site, but think of a PDF as being more of a digital format or more of a model where you could see the entire project all at once. And so that's kind of what this picture is illustrating here, is that basically we took away the limits of the size of a sheet, or the size of, basically the size of the digital sheet of paper that you could put on a project. And I think there's some little graphics here showing a roundabout project where You know, a lot of times you go into a trailer, a job trailer, and the construction engineer has taken all the plans and they stapled them together so that you can see the whole project at once. Well, by using the project PDF, it basically allows you to do that. You can print it out on a roll plot and be able to see and visualize the whole project rather than going through sheet by sheet by sheet by sheet. And we're going to get into some of the feedback about these pilot projects and just kind of how it led into what we're doing today. I think here we have a little video. This was one of our initial pilot projects where we actually were trying to take this thing to the next level, where it was almost like being in CAD. You can see we have different design files and different layers that you can toggle on and off, kind of like being in CAD software. So you can print those things to PDF. And we also had these different layer groups, which was really cool. If I go along in the video a little bit, where it kind of grouped a sheet of paper based on location or even based on work type. So this is just one PDF that you can very quickly flip between the removal details, the construction details, the pavement marking details, things like that. Now, what we learned really quickly on these pilot projects is that PDF is not the right way to be able to show some of this information, especially with all these layers. I think I have a slide showing this later, but basically what we found is that the mobile technology at the time, iPads and phones and even laptops that were not of a certain horsepower, the PDF software really struggled to render all of these layers, and it actually changed the way that we printed a lot of our pilots. And so I would say these early pilots, while they were successful, they definitely weren't perfect, and there were things that we could improve upon. And so definitely, I would say talk to us if you're thinking of doing pilot projects involving strip maps or really, really large pieces of paper, and we can give you certainly a lot more feedback than I can fit into a 15-minute presentation here. But overall, some of the early feedback that we got, the designers love it. Drafting time was significantly reduced as far as the amount of time and effort that it took to put labels on plans. Estimators and office staff, for the most part, really liked it. We heard from a lot of estimators that said it saved them time. Being able to visualize, especially the staging details and traffic and things like that, was really, really nice. And they didn't have to tape the plan sheets together, which was cool. Although a lot of times this still wasn't being done necessarily in a digital environment. It was the office staff literally printing out, 200-inch sheets of paper and taping it on the wall. And so while we initially envisioned this as being kind of a digital process, it was really still was a paper process. Whoops, in a lot of ways. Hit the wrong button there. Go to my next slide. Some feedback from the field staff. The tablets that we had in 2015 definitely could not handle the layers. We had iPads that were running out of memory, and our construction staff basically had to use their laptops instead of using some of their mobile devices. So definitely, like I said before, trying to print all of those layers to a PDF file, it's just not the right. It's just not meant for that, at least not on a big 200-inch sheet of paper. And patterns we found were especially slow. So if you had a lot of like hatching or things like that, definitely overall, I would say a lot of mixed feedback on the field staff side of things. There's definitely still, I would say, a perceived need to have a printed copy of the plans that's easy to carry around and easy to look at while you're on the job site. Another piece of feedback that we got from contractors too, specifically, this is just one example, but the pavement marking contractor in Michigan, they were like, they just told us straight up, look, we're not going to give our guys expensive laptops to look at the plans because what we do is messy. There's paint that gets everywhere, and it's a dirty job. So if you get paint on a set of plans, well, you just print out another set of plans. If you get paint all over a $2,000 laptop, then you might be a little upset. And so definitely a lot of mixed feedback on the field staff side of things, I would say, with the project PDF. But learning from those early pilots, I would say, and the work for the BIM for Bridges Pooled Fund, especially, which Brad Wagner is a part of, helping with this presentation, led us to our first model as a legal document pilot on I-696, and also our second model as a legal document pilot on M53. I've been saying M15 all week, so I'm glad I got it right, saying M53, which Melissa is going to present about. And so I'm going to quickly go through. Again, we're really limited in time for this meeting, so I'm going to try to quickly go through some of the feedback that we got on this I-696 pilot. So the scope of work for this project was replacing a 3-span steel plate girder bridge with a single-span bulb T-beam bridge over the Rouge River in the metro region, kind of in the Detroit area in Michigan. And this was part of a larger road reconstruction project. So along with this project, there was 8.5 miles of road work and 10 bridges that were being rehabilitated on the project. As far as the model as a legal document portion, where the bridge that you see on the screen here was the contractual document, that part only applied to this bridge. So the rest of the project had conventional plans associated with it. This project was let in August of 2022, and it actually just construction just finished up last winter in 2024. And so we've had a lot of good feedback in doing kind of like after action reviews with the contractor and things like that. As far as the feedback that we got is on this project, we're going to show the deliverables a little bit here. But I think if I could give any advice to any other DOTs that are thinking about doing this, this slide is probably the most important one. So number one, we had the designer on board through the construction of the project. And part of their responsibility was updating the 3D model, doing training with the contractor, and also doing lessons learned, keeping track of all of that stuff so that our next pilot would be even better than it is today. Definitely a lot of time and effort that was invested into this project. And so I wouldn't say it was anything where we were expecting to go in and save a bunch of money on this project. We wanted to do it the right way and make sure we had the right coordination and the right people in place to make the job successful. And the other thing was this model coordination and training SP, which we included as part of the contract, which required the contractor to develop a BIM execution plan. We had bi-weekly meetings about work that was going to be done using the 3D model in the field. It required them to capture lessons learned and to give us a presentation at the end of the project. And so definitely, I would say some extra effort on the contractor side too, of things that we inspected of them, just to ensure that the project went well. But definitely well worth it to include these items on our first pilot project where we didn't really know what to expect. And this was the coordination in the partnership between MDOT and the contractor and the field staff and the survey staff was something that, and the construction staff, something that everybody agreed went really well on this project. And I think this SP was a big part of that. So I'll try to get through this as quickly as possible. So the software that we used for the model viewer on this project was a Bentley product known as Bentley Synchro. And this is just a little video showing that product in action. So one of the things that the design teams, or one of the things that we learned quickly is that expecting a contractor or somebody not familiar with our CAD standards to toggle on and off individual layers or files is something that's not really feasible. And so what Synchro allowed us to do is create these saved views where it was the designer's responsibility basically to turn layers on and off and give the contractor the typical views that they would be used to seeing. So kind of mimicking what a plan set would look like, but in a 3D environment. And so definitely having these saved views was something the contractor pointed to as being really valuable. And they said on future projects, they would want these saved views to be more standardized and maybe even have even more of them on a typical project. The other thing that went really well on the field side of things was this idea of data visualization. So again, this is something that is that the model viewer that we used on this project, Infrastructure Cloud, can do. But it's basically this idea that when you're in a 3D environment with things that have properties, the idea of toggling layers on and off, it's almost a foreign concept. It doesn't even matter. You can toggle things on and off based on their properties. And so that's what we're showing in this little visual is we have a whole big old mess of 3D reinforcement on this bridge abutment. and it's basically impossible to see when you have all of the reinforcement turned on. But one of the things that the design team did on this project is they tagged as an additional property what the MDOT bar mark was for that particular reinforcement. And so by doing things this way, I can go in and I can turn on an individual bar mark and look at things a little bit different, where it grays out, you know, most of the model, and I can just really get into the details and see exactly what it is that I want to see. And so definitely the data visualizations and doing as much as you can with extra attribution in the model is something that can really add value to a model as a legal document project. Another thing that the contractor said is they found the RFI process to be a lot easier to communicate what they wanted. And really, this was just having the 3D model is what improved that. We didn't change our RFI process from what it normally is, but the contractor was able to get into the 3D model, take screenshots of exactly what it was that they were looking at, and provide some additional context for the design team or whoever was reviewing those RFIs. And so I thought that was, excuse me, an interesting piece of feedback from the contractor. As far as some of the opportunities or some of the things that didn't go as well on the project, I don't want to paint a picture like this was all, you know, the perfect pilot project where there were no issues and we can't do anything better. Certainly, the contractor said that getting bids from subs was really, really difficult. And remember, this was just one bridge out of a much larger project. But basically, during the bidding phase, they said they had to, you know, essentially take screenshots of the model or do their own quantity takeoffs to provide subs, where it was a lot of extra work on the prime contractor to get bids during bidding time. Another thing that we found is that for construction staff, whether it's an inspector or somebody from the contractor's team, the idea that you could take an iPad or some kind of mobile device and take measurements in the field of the 3D model, it's really not feasible, you know. And it's not even that you don't have enough screen real estate or anything like that. It's just you know, being able to take your finger and snap exactly on a point in the 3D model and be confident that you're getting to the right spot. We found that it's just really not feasible. And even in the screenshot, I'm not sure how well you can see here, but you get little oddities like this where you have something measured at 4.001 feet. Well, that's probably not what, you know, it's probably supposed to be 4 feet and not, you know, whatever kind of rounding issue is going on here. So little things with the model viewer like that too, we found as being an issue. Another thing that the contractor said would have been helpful is having more 2D annotated views. And I think this just goes back to the same thing that was on the previous slide. Having a 3D model with no annotations, it's not really feasible in the field on a mobile device to be able to go in and take your own measurements on the 3D model and be confident in it. And so this thing that looks like a plan sheet on the screen, that was something that was included in the model for this project. Basically, it's I mean, it is the 3D model that you're looking at. It's just been modified to look more like a plan sheet, and actual dimensions and annotations have been put on it. So something that looks a little more like a conventional plan sheet, maybe not for everything that we include in your typical project, but for a lot of the work, having more of those 2D annotated views was something that they pointed to. Overall, just a summary of the feedback. I think that partnership is really important if you're doing any kind of pilot projects. Definitely, that was a big reason why we were successful on 696, because of the attitude and the partnership that every party brought to that project. I would say in general, the office staff is really flexible with the deliverable that you give them. And on the field staff, it's a little more of a challenge. Things are slow to load on mobile devices. If you don't have internet connection, that can make things difficult. And overall, I think that for the most part, field staff, by and large, the feedback has been that it's been more difficult to navigate than a traditional set of plans. And so I guess from my perspective, I wouldn't necessarily, this is MDOT's perspective, but from my perspective, being a part of these different pilot projects, I think it's really important for the plans and the model to work together. And so this is kind of the simplest example I can think of. We have, you know, a nice isometric view, a plan view, and a top view, but everything is linked to the model, right? So if you change anything that is in the model, where I just changed this footing from 2 feet to 3 feet, your annotations are all, adaptive and update with it. So the idea of parametric modeling and parametric plans is the thing that I would support, and I think is I guess potentially another way of delivering things in the future, where instead of getting rid of all of the plan sheets, you have kind of this hybrid mix where you have the plans and the 3D model working together. So with that, I think I'm going to turn things over to Melissa to talk about our second model as a legal document project on M53.
Do you see my screen okay?
I do not think I see it yet. I stopped the share on my end. Might try resharing. Yep, we got it now.
Okay. Well, I'm gonna give a brief overview of where are we at with our second pilot project, location, type of structure, and we're gonna be also discussing about external and internal stakeholder engagement. Michigan Department of Transportation is composed of 7 regions. The project is located on M53 over Greenman Creek in Sunny Lake County, which is part of the Bay region. And this county is just next to the Lake Huron, so it's on the east side of the state. It's a little bit of a rural area, and in order to get the transportation service on board and the region, we did some testing on internet connectivity that was successful, and that helped us to get the buy-in that we needed from the region and the construction office. The existing structure is a 24-foot span bridge that will be replaced with a precast concrete culvert of 30-foot in span and 10-foot rise. So some of the goals for our project is that, as Luke mentioned, the 696 project, AMLD included just the bridge. Here, we want the road and the bridge to be part of the contract, the legal contract. And so that's what we're working on. As part of this project, we have started engaging industry, contractors, and fabricators. We have also implemented digital milestone design reviews utilizing Bent Infrastructure Cloud. We want to gain knowledge and to establish how the shop drawings delivery format and process needs to look like for this project, as we will be requesting, and they are required for the precast concrete culvert. Shop drawings are required in all culvert projects. We want to gain in-house modeling experience utilizing OpenBridge Modeler, utilizing templates and solids. And we also want to gain more experience with ORD doing earthwork and riprap at these bridges over water. And we are planning to include the board logs as part of the reference for information only. The board logs are in 3D are not going to be contractual, but they are going to be part of the reference information documentation that we provide with every project. Yeah, sorry. In this figure, we can see we're showing the excavation limits and the proposed structure that was also modeled in 3D. As part of the MDOT outreach, we have assistance from HDR. They are our consultant partners. They are not doing the design. They will not be the engineer of records. However, they are supporting our bridge design team with training. They are also assisting with training and outreach for internal and external stakeholders. As part of MDOT outreach, we have been having training and conversations with the reviewers for all milestones during the design process, our hydraulics unit, our geotechnical unit, and the construction staff as well. How we have delivered this training? Well, a lot of our work nowadays is done in a virtual environment that allows to get to more people all across the state in our case. So we provided initial virtual meetings. We separated into 2 different sessions. The sessions were recorded and made available to everyone to go back to those recordings and do at their own pace. Also, look here, help us out to prepare documentation with the step-by-step procedures to use the Bentel Infrastructure Cloud, and how to look at the model, what they're looking at. Here we have a screenshot. This is coming from the Bentel Infrastructure Cloud, which is a web-based platform, from one of our review sessions. And this is just a summary of the comments. And on the right side is the properties of the elements that were selected in the model at the time that we took the screenshot. This is more of Infrastructure Cloud. We're showing a lot of it because that's what we're using for the design review, not just for the milestone, but we're also using for internal reviews when we need to seek clarification from our hydraulics unit or our geotechnical unit, for example. And this is just showing a summary of recent activities of whoever is reviewing it, right? Because this is, you need to have a login in order to get into this session, right? And then just a summary of what the comment was. We can tag a location to that comment so that we can have subsequent discussions if it's something that needs to be further discussed. So as part of our external stakeholder outreach, we also include our state partners, the Eagle Environmental, it's called Environmental Great Lakes Agency, formerly DEQ. We reached to them to see if they will have the time and we could get them on board as part of the permit application that is required for this project being over water. And due to short staff, they cannot do the review and learn the process for this project. So what we proceeded to do for the permit application is to create digital sheets, kind of similar to what Luke showed on the 696 project. These digital sheets are created from the model and are not annotated in the model, but then we can convert them into PDF files. Our intention is to provide key information on our project, what are we doing, the location of the culvert, the realignment of the culvert, but we are not intending to duplicate traditional 2D PDF sheets. In addition, we have reached out to contractors, fabricators, and industry in general, because we want to make them aware of the project ahead. We want to seek input and feedback, what works, what doesn't work from them. And similar to the 696 project, there is going to be a mandatory pre-bid training during the advertisement phase of this project. At this time, the project is scheduled for a September 2025 letting with a 2026 construction. We are providing optional training prior to the advertisement period, and it's up to them if they want to participate or not, as we cannot force them. However, it's highly encouraged, and we are basically sending emails every week to remind them about our upcoming training. We also want to seek input in the BIM execution plan, in the special provision that is for the model coordination. We want to engage them on digital sheets information if we need to create more, on additional savings that could potentially benefit them in the field and during the fabrication process as well. And talking about fabrication process, we need to engage them more in shop drawings, as we want to request digital information. We're still navigating those waters. Any potential for rework workflow for fabricators processes using IFC. And we did have some initial discussions about what should be the contractual model, and we're gonna stick to the DGM file being the contractual element. So how are we spreading the word, and how are we doing this outreach for stakeholders, contractors, and industry in general? So we are doing webinars. Our first webinar was second week of February, and it was an introduction to the project. We are also engaging with MIDA, which is the Michigan Infrastructure and Transportation Association, to assist us with their press release to share the upcoming engagements. We have been putting together, and HDR has been a tremendous partner with us on these. We are putting together, or have been putting together, an email contact list. So anyone in that contact list is being receiving information about upcoming engagement webinars. We are doing also via our M.E proposal, what we call a contractor announcement. It is tied to current letting, and then we are putting information there. We're also doing, as I mentioned earlier, M.Gov delivery emails. And this is just a snapshot of what it looks like. Just give them an intro to the project, some of the goals of the project, and then it goes into upcoming engagements. We have a calendar appointment, which is with the series of appointments that we have planned thus far, so that they can have that on their calendars in advance. We are also working on a project website, which is going to be dedicated for contractor, fabricator, and industry outreach. It's not so much for the public, but it's to be able to share these recording webinars as well, which is working through the ADA compliance. So hopefully we'll have it resolved or completed by the end of the month. So some of the challenges and benefits with the use of, or with the 3D project in general thus far, is that in terms of challenges, is that we have found that OBM does not have established templates for culverts. So we have to be doing some rework around, because from time to time, some of the templates get disconnected from the element, and that element then becomes a solid, which means that we cannot simply go into the template and make any updates to that element. And we have also tried to better understand and gain more experience on when we simply need to use solids and not even bother with the templates, because it's just not going to do what we need to do here. Clash detection, details coordination between all our disciplines involved in the project. And one of the big aspects has been riprap visualization. We had a lot of back and forth with our hydraulics unit, because there were concerns about us filling in the existing stream bed. So after some additional communication using the model, showing it through Bentley Infrastructure Cloud, cutting cross sections using Bentley Infrastructure Cloud as well, we were able to determine that it was best to reduce the rise of the culvert and do some playing with the slopes in order to avoid filling in the existing stream that could cause an adverse effect. As part of the clash detection, we found out that the existing gas line is in close proximity to the temporary cofferdams enclosure for the construction of the project. So this gas line now needs to be relocated, so there is no conflicts or close to a conflict, and we comply with MIOSHA requirements. As part of the coordination, bridge and road design have been coordinated throughout the entire project. We have a container file with all the sub-files being referenced to it, so everyone can see the most up-to-date information. But we also needed to do some subsequent coordination on shoulder elevations, which help us to determine the wing wall heights and lengths that we needed to ensure that it will work out with the new shoulder location and widths and elevation. So that was very useful and helpful to have a 3D model to go through that. Another benefit is asset management. We're still getting more into what are we do with these, how are we going to have a living document. It's going to help with inspections, with the future work that it's going to be done. And then hopefully once AASHTO Open API is up and running and the case studies have taken place, we can see how we can exchange data between an OPM ORD model to AASHTO Bridge Management or AASHTO BRM. So we're still looking into that, more to come, but this is some of the things that we have done thus far with our second pilot project, and now I will pass it on to Brett.
So I think we're running a little bit tight on time, so I'll do my best to go fast. But I want to kind of zoom out and look at maybe the 30,000-foot view of this whole discussion. So I think these pilot projects that Melissa and Luke have talked about, personally, I think they're pretty awesome. I think they're pretty innovative. We're doing some great things. But really, they're an advancement, or they represent an advancement in just one small area or one small piece of the overall life of our transportation assets. Really one link, if you will. And I want to touch base on just several other efforts that we have ongoing related to data-centric workflows. So back in 2015, one of the EDC4 initiatives was e-construction. And at that time, I think MDOT was fairly well down the road in terms of implementing e-construction, and a lot of our practices were showcased at that time. And while e-construction is really just sort of an electronic emulation of what we used to do via paper, it really forced people to think about workflows, and particularly standardizing workflows, repeatable workflows, which is it's super important in order to ensure the integrity of data as we expect things to get used by others. Another thing we just wrapped up last year is our construction tools research project. This one was pretty neat. And it looked into the needs and use cases for, digitalization is a mouthful, particularly as it pertains to our construction staff and field uses in construction. And this project really highlighted how our workforce is changing, and how the demands of our younger generations, really how they think and they learn, really is conducive to working electronically, and really expected for what you will, or for what it's worth. I think one thing that was really a takeaway from this is our field folks, like probably everybody, are getting bombarded from every direction with new tools and technology, which leads to a lot of challenges and a lot of questions, as you see the little guy with questions here. The project also explored and evaluated a lot of tools that are currently available. There was discussions about automated machine guidance and demonstrations of that, as well as drone capture and a lot of the neat stuff that you can do by capturing images with a drone. Next up, we have our transportation asset management data assessment. So this is basically looking at, within our asset management, 16 different classes or asset areas, including pavement, bridge, signals, several other areas, and really look at how they're using data, how their systems support and use data, and looking for, potential improvements. And ultimately, we want to get to a place where, we can enable our asset management systems to better support program-wide enhancements, really to allow for network level insights and make better decisions on how we allocate the money that we have. Right away to GIS, I think, is a big one. In many cases, our right-of-way maps, they were hand drafted many years ago, and trying to bring that information into our current environment was really a challenge. And so several years ago, we moved everything to PDFs. That was helpful, but not as helpful as it could be, because the information is basically locked into those PDFs. So this effort really looks to digitize that right-of-way information into a GIS environment. And going forward, we're going to make that even more useful by establishing a digital workflow by which new parcels can be ported straight into that GIS environment. So this one's a bit broader: data integration and warehouse design. It's a mouthful, and probably a little bit more abstract maybe than the others. But obviously, we create a ton of data nowadays, much more than we did in the past. And so it's more critical now than ever to organize that data in a logical way, make sure it's manageable and sustainable, as well as scalable for the future. And so I think these graphics do a good job of really explaining what's going on. We've got a lot of point-to-point or system-to-system connections that data gets handed from one system to another. And essentially where we want to be in the future is, to have a data hub that basically includes all of our data from all of our systems, which, obviously makes sharing of data much more efficient. So we basically would pull the information from the system of record. We'd get rid of any inconsistencies, and we would, basically, by doing that, improve the quality and enable ourselves to be more cloud smart, or able to adopt a cloud based environment. So these are just a few of the great things that I think are representative of, innovative things we're doing. But there's many more that, we could talk about if we had time. But they really, I guess ideas can tend to lead to more ideas. And, a couple of years ago, we noticed something that, people were experiencing change fatigue, getting hit over and over again with new and different things. We were experiencing a lack of traction in a lot of different places in terms of, like with these pilot projects, when we look for, someone willing to take on a pilot project, sometimes that was difficult to get buy-in. Other times, industry may not have liked what we were doing, and really, in all essence, stop things in their tracks. So I think a lot of this stems from our lack of a really clearly defined priority. Everyone's busy, everyone's got a lot going on. So, many of the initiatives that I just shared were really limited to one phase of a life cycle. So like these, pilots are designed to construction. But in turn, I guess, conversely, we saw a lot of commonalities between a lot of the things that are going on. Everyone's looking to use technology to capture efficiencies. We'd like to get to a point where we create data just one time. And ultimately, I think we strive for better clarity, and using data to do so. So that's what brought us to pursue what we're calling our digital vision and roadmap project. So we really saw a need to have a statewide vision. What does MDOT's digital future look like, and how do we get there? So, I mentioned all those efforts we have going on, and essentially, what we need to do is we need to get those efforts in alignment and make sure that everyone's aligned into kind of the same orbit. Ensure that everyone's focused on the same high level goal. And we hope that, by establishing a vision and charting a roadmap, that'll help us get us there. So when we set out on this project, we thought it was important to establish, the gravity of what we're trying to do. And so we started with the core team that basically represents, virtually every area that touches our assets. We have our sponsors, which are our bureau director level folks that are, highly engaged with the project, but at a level that they actually advise and support our department leadership. So really will help with buy-in when the time comes to really when we get rolling on this full out. We also saw the need to have a national partner involved, or a consultant partner involved, and really to bring in, a national perspective and expertise. And WSP's been doing a great job of supporting us on that. So we really got rolling with WSP late last year. There's a lot on this, and I'm not going to really get into a lot of detail on what's here, but the star is basically kind of where we're at. So we had something called a digital vision workshop, which I'll talk about in a second, but we're basically about a quarter of the way through, what will be about a 2-year effort just to get to the point where we can roll full steam ahead and actually start implementing this vision. So we had a digital vision workshop about a month ago. This was attended by over 60 people that represent, basically, again, everyone who touches our assets within MDOT. So design, construction, asset management, what have you. We also engaged with ACEC to bring in consultant partners with expertise in planning, design, construction, inspection. And then we engaged with, it was previously mentioned, MITA, our Michigan industry representation, to bring in contractors to really have a voice in the discussion. And so, through a day-long workshop, we developed a more uniform understanding of, what digital and digitalization means for MDOT. We came up with a draft vision statement, and we identified a number of priorities that are going to be used to feed into our roadmap in order to implement this. So just to kind of wrap up here, I often get asked why we're doing this digital vision effort. And, most often, it's not a why that's trying to be obstinate or questioning, like maybe this young person is doing here, but rather a why that's really attempting to understand, so a person or people can better get on board. And, I think most people understand that we can benefit from better using technology, and many are willing to do so. But I like to think of it more instead of why, kind of think about the what if, dream a little bit. And, to do so, we kind of start with what's our biggest challenge? I think one of our biggest challenges is the fact that, when we pass an asset from different phases of its life cycle, we often lose, I don't want to say lose, data gets locked in to those different phases. So instead of having that nice smooth curve where we're building data for an asset throughout its life, we have these fits and starts that you see, in the lower chart there. And I think there's a lot of reasons, non-connected software programs, information shared as static documents, improper data standards, really no formal structure to data, which really makes it not useful to those downstream. And so the example that I like to use as, maybe the gold standard or something to strive for is, our what if example here. So look at Google Maps and Waze. I'm sure, everyone that's on the webinar today has used one or both of these. And really, this is benefits from real-time smartphone data to share location, speed. We get traffic information. And this, essentially suggests routes. It estimates arrival time. It can adjust directions on the fly in order to get you from point A to point B. It also gives additional benefits like, suggesting a different route if there's a delay. It can share things like speed traps and, debris and things like that. And so this is really, in my view, a great example of seamless real-time data sharing, where thousands of vehicles share information to ensure the most efficient way for all to get from point A to point B. And this really relies on, the ability to share data efficiently. So, while we build roads or bridges or pavements or what have you, that's never going to change. But hopefully, everyone will agree that, the better use of data and technology really will allow us to make, faster and better and wiser decisions more efficiently in the future. So last thing I just want to leave with. So one thing that we really tussled over as we went into this digital vision project is, what does digital mean? And so I figured I'd ask Google, and I thought what I got was a great example. Ask Google what digital means in 2025, a highly integrated, data-driven, user-centric environment where technology seamlessly permeates everyday life. And I think that's where we want to be, and that's what we strive for. And I think we as an industry, and certainly, within Michigan, we are poised to try to get there. So with that, it's like we have a little bit of time for questions.
Great presentation. We only have a few questions. I think we can get them. I'll just start from the top. Bridge lines are temperature and load dependent. Did you specify the load conditions, still dead load fit up, and temperature conditioned, assume 60 degrees Fahrenheit in the bid documents?
Yeah, I can handle that one. I think it was done no differently than we do 2D plans. We basically, we don't officially say 60 degrees. There's actually been some back and forth about that within folks within our department. But we basically looked at that finished condition at a normalized temperature, and that's what we modeled, the same as we would do for, a 2D set of plans.
I-696, what was the reason you did not use the infrastructure cloud ability to mark up on the model instead of taking screenshots and marking?
You want to take a shot at that one, Luke?
Yeah, I can handle that one. So, we were at actually a really interesting time at MDOT as we were getting ready to advertise and let this project. At the time, we were going through a security review with Bentley and Infrastructure Cloud, and when the project was approaching letting, we didn't even know what our model viewer was going to be. We were given the contractor Bentley View, Open Roads Designer, other products from Bentley to be able to view it. And we ended up finding a way to be able to use Infrastructure Cloud on the project, kind of at the last minute. So I would say that was part of the story, but also one of the things that, well, you got to remember this was also 2022, 2023, so 3 years of development on the product that's still been going on, and so some of the features that we have now might not have existed back then. Like I know, for instance, if you were to take a measurement on the 3D model, you couldn't save it and have it be there the next time you opened a session, and things like that. And so specifically for making dimensions on the model, that was a part of the problem at the time. But I think
Yeah,
that's
I think I would contend too that, I don't want to take all the responsibility, but we had Bentley very heavily involved with that project. They were sitting in on regular meetings, and so I think they gleaned a lot of feedback from the challenges that we were having. And I think a lot of the capabilities that are in Infrastructure Cloud today, and to some length came from some of the feedback we had from that project.
In the I-696 example, did the contract use the model as a legal document approach, or was the model provided as information to the contract?
It was. We provided both. So some of the model information was reference information, but a lot of it was contractual, and we had a listing of which files were contractual and which ones weren't. For that project, and also for M53, we're saying that the authoring software's files are the contract documents. So the actual DGN files, even though we can view the model in Infrastructure Cloud or other model viewers, the actual contract is the DGN file in this case, or Excel files or other things that we might provide. But yep, 696 did use model as a legal document.
Got one person that's sent in several, so let me choose one. Why did you decide to interview Utah, Iowa, Minnesota, Florida, and Georgia versus other states?
I guess I could take that one. I think in part, it had to do with just their having done a model delivery pilot, or at least a model-based pilot prior to us, particularly as it pertains to New York, Iowa, and Utah specifically. And so, I think I would say personally that we were inspired by learning about what they did in order to be willing to take the leap into, our efforts.
Did you update the model to reflect as-built conditions so it could be used for future inspections and managing the assets?
Yeah, the design team for I-696 was on board through the entire project, and as changes were made, they would make those changes in the model authoring software and synchronize those changes back to Synchro, which was our model viewer for that project. So yeah, all of the as-builts were captured in DGN format.
Were all the pilot projects traditional design bid build?
Yes.
So far, yes. We have, for project PDF, we have had some design build projects where the contractor and the designer elected to use that. But as far as the model pilots, yep, design bid build.
Ask one more. It's already 1 o'clock. Do you have a summary of your construction tools research?
Yes. We should have a research report on that. And I actually was going to try to put a QR code for it into the presentation, and I ran out of time. So I think that's something that we can get out. I don't know if you have a way to distribute. Otherwise, feel free to reach out to one of us. We got our email addresses on there, and we'd be happy to get that to you.
right, we are at 1 o'clock, Trish, or 1:01, so I don't think we can get to the rest of the questions, and just want to send out a shout out and a thanks to everybody for participating today and for presenting.
Thank you. Appreciate it.
Thank you, everybody.